Hello, this is Mr. Stein. In this video, we're going to look at our pre-unit assessment for capacity. Right, so let's take a look at question number 1. From the following examples of measures, would you need an exact measurement or an estimate? So an estimate just means you have to get close. It doesn't matter if you get it exactly on. You can be off by a little bit. Some things you need an exact measurement for. So you're filling up a pond. You need to measure the amount of water to fill a pond. Do you need to know exactly how much water, or would an estimate do? Well, in this one, most definitely an estimate would work. Because you just need to get it close. If you need to add a little more, take away a little bit after, you can do that. That's no problem. But an estimate, you want to get a close amount. Measuring the area of a long jump pit. So you've got a long jump pit out in the yard for track and field. You want to measure the area of it. Well, most likely an estimate will be good enough for that. You don't need to know down to the exact square centimeter how big it is, but just get a rough estimate. How high a high jumper jumps. So in track and field, when they jump over the bar, what do you want for that? Well, that needs to be exact. You want to know exactly how high that jumper jumped, so you can compare them to all the other jumpers. Measuring liquid medication. Well, liquid medication, you get exact measurements for how much a person should have. So that would be an exact amount. You need to know, because there might be consequences if you take too much, or it might be ineffective if you don't take enough. Number 2, provide an example of a time when you would need an exact measurement to accomplish a task. So, for instance, when you are building a house and you need to measure how tall the walls are, you need to know exactly how tall the walls are. So, measuring lumber for building a house. You want all those boards for your walls to be cut to the exact same length. Otherwise, your wall will be a little bit wonky, be crooked in height. So they need to be exact. Provide a referent for a liter or millimeter and give a reason for your choice. So a referent is just an everyday object that is about that size. So for a milliliter, a milliliter is actually the exact same size as a cubic centimeter. So a large blueberry that would be a good reference for a milliliter. For a liter, a normal size water bottle. A lot of water bottles are pretty close to a liter. The one that I have, my Gatorade water bottle, is 710 milliliters, so it's just a little bit small. So a good size water bottle is about a liter. So you'll have to look at your water bottle that you have. It might be 900 milliliters, and that's pretty darn close to a liter. All right, question number 4. Please convert the following to milliliters. Remember that 1 liter is equal to 1,000 milliliters. So we multiply each of these liter amounts by 1,000. So 5 liters is 5,000 milliliters. And 5 liters, that's a little bit bigger than an ice cream pail. 3 liters would be 3,000 milliliters. That's a little bit smaller than an ice cream pail. Ice cream pails are about 4 liters. 8 liters, times it by 1,000 to get 8,000 milliliters. That's 2 ice cream pails. 1 liter is 1,000 milliliters. Good size water bottle. 4 liters is 4,000 milliliters. That would be 1 ice cream pail. Number 5, it's your turn to change the water in the classroom aquarium. It has a volume of 20 liters. What common household container would you use to fill it? Explain your choice. Well, 20 liters. We could use a variety of items. For instance, we could use an ice cream pail. Ice cream pails are typically about 4 liters in size, so it would take 5 of them. You go to your cupboard and get a pot. Pots have different sizes from well, you actually have like a whole bunch of different size pots. From a ½ liter to 2-liter pots. Sometimes there's 4-liter pots, 3-liter pots. So that'd be another good one. A 2-liter pot, it would take 10 pots. 5-gallon pail. You could use a 5-gallon pail, and a 5-gallon pail is about 20 liters in size. So there you have a couple of items that you'd use. You would not use a teaspoon, which is about 5 milliliters. That would take forever to fill up. Number 6, sort these pictures of containers from least to greatest capacity. Explain the reason for your choice. Note they're not to scale. All right, so what I'm going to do is I'm going to give them each a letter. A, B, C, D, E. Now, I'm going to sort them from least to greatest. Least being the smallest. Well, this is liters, milliliters, liters, milliliters, liters. This is not even 1 liter. This is not even 1 liter. So these two, B and D, are our smallest. B is 225 milliliters, so that is definitely the smallest. Next, D is not even a liter, so D would be the next smallest. Those two are less than a liter. B and D are less than a liter. So the next ones are a liter or bigger. Well, we've got E, the pot, is 3 liters. The paint can is 4 liters, so that'll go next. And lastly, the bucket, that's 8 liters. That goes last. All right, I hope you didn't find this too difficult and that you found this review helpful. If you have any questions, please contact me, and thank you for watching.